All right, indicator 15.2. We're still in system of equations. We're still dealing with elimination. Only today we have to do a little bit more forceful manipulation in order to get one of our variables to eliminate or cancel out or zero out. Okay, I kind of use those three terms interchangeably. Eliminate, cancel, zero out. It all means the same thing. It basically means to go away. Okay, go away to zero. All right, so remember I said with these equations, you cannot just jump in and draw a line under this and start solving these. When you're dealing with system of equations, you need to stop, kind of pull back a little bit, and take an overview of your whole problem. And you need to critically think through some things. First, look at your x's. You got 4x and negative 2x. They obviously don't cancel each other out. You've got negative 8y and negative 1y. Those don't cancel each other out. So, and it's not even something little like, if we run a negative 1 through it, we can make two 4s a negative and a positive, okay? That doesn't work. So we got to get a little bit more forceful or do a little bit more thought process of what are we going to multiply our numbers by in order to still make something eliminate. Remember, our goal of elimination or zeroing something out is to have the numbers match, but the signs be different. So my x's, my signs are different, so that's good. But my numbers don't match. But I can, as long as I do it to all, right, is I can multiply something into that whole bottom equation. As long as I distribute it to all three terms, I haven't broken any math rules or changed the value. I've just rewritten it. So what could I multiply the bottom equation by in order to make it cancel out with the top? A 2. Now, it's a little time consuming, but I really caution you, don't shortcut this. Take the time to rewrite that top equation. So 4x minus 8y equals 4, okay? Because you really want your two good equations right on top of each other. Now we're going to make that bottom one work by multiplying a 2 all the way through it. So 2 times negative 2x is negative 4x. 2 times negative y is negative 2y. And 2 times 8 is 16. Now I'm ready to draw my line. And now I'm ready to cancel or not combine like terms. I'm ready to combine my x's, combine my y's, and combine my whole numbers on the other side of the equation. So when I have 4x minus 4x, I get what I wanted, which is my x's cancel out. And really, they zero out. They go to 0, but I'm going to be lazy and not write the 0 down there because I don't really need to. Then I combine my y's. I have negative 8y and negative 2y, which is negative 10y. And then on the other side of the equal sign, I have 4 and 16 to combine, which is 20. Now I need to get y by itself. It's attached to negative 10 with multiplication, so I'm going to divide it off. If I do it to one side, I do it to both, right? That's the rules of math. So I get y equals 20 divided by negative 10 is negative 2. That's half my answer. To get my other half of my answer, I'm going to go back and I can use either one of my original equations. I can use my manipulated equation. It really doesn't matter. I'm going to go ahead and use that top equation. So I'm going to use this one right here. So I'm going to write 4x minus 8, and I'm going to put parentheses where there was a y equals 4. That's that top equation. But instead of putting the letter y, I'm going to put what I now know y equals, which is negative 2. So I'm going to plug that extra piece of the puzzle in. And now I'm going to distribute because PEMDAS always says multiplication or distribution first. So negative 8 times negative 2 is positive 16 equals 4. Now I want to get my 16 over there with my 4 to combine those. So I'm going to move it. It's currently a positive 16, so I'm going to minus 16 from both sides, which leaves me 4x equals 4 minus 16 is negative 12. You subtract the two numbers and take the sign of the bigger when they're opposite signs. Still need to get that x by itself, so I'm going to divide by 4 and divide by 4. And when I do that, I get x equals negative 12 divided by positive 4 is negative 3. Almost done. My answer is the ordered pair that this creates, which is negative 3, negative 2. And that's the final answer. Okay? So, same thought process, same idea of trying to get one of your variables to zero out And the way you do that is matching numbers, opposite signs. All right, so let's look at another example. Give you a minute to get it written down, or a few seconds to get it written down. If you're at home, please make sure that you are writing all these examples down in your 3-ring binder so that you can get your note checkpoints. I think that gets longer some days, doesn't it? The bell. All right, so again, right before we draw our line and jump into this and start working it, we need to pull back and we need to look. We've got 9, positive 9 and positive 10. They don't cancel each other out. We've got negative 5 and positive 8. They definitely don't cancel each other out. I can't multiply the 9 by anything to make it a 10. I can't multiply the 5 by anything to make it an 8. So this is one where it's going to require a double multiplication. So when that's the case, right, you're going to put brackets around both equations. And now you are going to have to decide, before you go any further, you're going to have to make a decision for yourself. Are you going to make the X's or the Y's? It does not matter, okay? Sometimes there might be an easier choice. It might be easier by just a little bit, but it doesn't matter. So everybody's work may not be the same here. One might choose to eliminate the X's, one might choose to eliminate the Y's, but in the end, you'll still get the same ordered pair, okay? So for me, because my signs are already different on my Y's, I'm going to go ahead and eliminate my Y's. And the way you do that is on the top equation. If I want to make my Y's go away, I look and see what is the number in front of the bottom Y. It's an 8. So I'm going to go to the top equation and I'm going to multiply that times 8, right? Multiply it by the opposite coefficient that you're wanting to make disappear. Likewise, I'm going to look at my top equation and see that that is a 5, and I'm going to multiply my bottom equation by a 5. So I'm crisscrossing. Now, don't worry about, it's a negative 5. That doesn't matter, right? Don't worry about that at this point. Just put your numbers there. 8 crisscrosses with the 8, 5 crisscrosses with the 5. Okay, now think through your signs. If I take 8 times negative 5, I'm going to get negative 40y. If I take 5 times positive 8, I'm going to get positive 40y. Are my signs going to be opposite? If so, then I'm good to go. And that's why I picked the y's, because the signs were already opposite, so I didn't need to worry about forcing signs to match up to. All right, so now we distribute. Remember that 8, and sometimes I even like to put it over on this side just to remind myself not to forget to multiply that 5 hanging on the end, okay? So 8 times 9 is 72x. 8 times negative 5y is negative 40y. And 8 times 5 there on the end is 40. That's the upper equation with an 8 ran through it. Now I'm going to run a 5 through the bottom. 5 times 10x is 50x. 5 times positive 8 is positive 40y. And 5 times negative 8 is negative 40. Now I'm ready to draw my line. Don't draw your line until you have all your manipulation done and you're ready to actually combine each column. So my first column, 72x and 50x, when I combine those, I get 122x equals 40 minus 40 is just 0. I still have an x to solve for, so I'm still going to divide to get it by itself. And I'm left with x equals anything with 0 on top is just 0. And I will tell you, doing this double multiplication, sometimes the numbers will blow up really big on you, but they always reduce back down to, on your homework and on quizzes and tests for me, your answer will always boil back down to a whole number, no fractions, no decimals, and it'll always be under 10. So if you get some crazy decimal or fraction, or you get some wild number like 84 as your answer, you've got a sign error somewhere that you need to go back and find, okay? All right, so now we know that x equals 0. So I'm going to go back to one of my 2 original equations. It doesn't matter. I'm going to pick that bottom one. And now I know that my x, right, I know the value of x now is 0. So I'm going to write 10 parentheses where there was an x plus 8y equals negative 8. And in place of the x now, I'm going to put a 0 because I now know that piece of the puzzle. Well, 10 times 0 just zeroes out to 0, so I'm not even going to worry about rewriting that. And so I have 8y equals negative 8. And then I divide by 8 and divide by 8 to get y by itself. And I end up with 8 or y equals negative 1. And so my answer is the ordered pair 0, negative 1. So no matter how big your numbers blow up in the whole manipulation and multiplying everything, you're always going to get down to some very basic whole number under 10 for your points, unless it's a no solution or an infinite. And then in that case, everything goes away anyway. All right. Any questions on that? All right. I'll give you a minute to write this one down. All right, so again, before we draw our line or even start solving this, we got to do a little bit of critical thinking here. We've got 3x and 6x. They don't cancel out. The signs aren't opposite, nothing. We've got positive y and positive 2y. Signs aren't opposite. They don't cancel each other out. So that means we got to do a little bit more work. Then it's kind of comes to, is it going to be a single multiplication or a double multiplication? Well, the way you figure that out is ask yourself, can I make a 3 a 6? If the answer is yes, it's going to be a single multiplication because all I'm going to have to do is manipulate that top one. Now, to make a 3 a 6, what do I need to multiply it by? 2. But before you distribute it, always ask yourself the sign question. 2 times 3 is positive 6, and I have a positive 6 in the bottom. So what do I need my upper to be? Negative 6, right? So I'm going to force it to be a negative 6 by multiplying by negative 2. Because when I'm done, I need the 6's to match, but I need the signs to be different. So in the top, I'm going to distribute that all the way through, right? So I've got negative 6x. Negative 2 times y is minus 2y, and negative 2 times negative 12 is positive 24. Now, I didn't do anything to that bottom equation, so I'm just going to rewrite it because you always want your systems stacked right on top of each other. And now I'm ready to draw my line and reduce each column or combine all my like terms. So negative 6x and positive 6x cancels to 0. Negative 2y and positive 2y cancels to 0. What do I have left on the left? Is it nothing? It's a 0, right? You can't ever have a nothing. So I'm usually lazy and I don't write the 0 unless it's the only thing there, then you have to write the 0. All right, now I have 24 minus 16, which is 8. All my variables are gone. Is this true or not? So my answer is excellent. Okay, any questions on that one? All right, I want to give you a minute. I want you to write this one down, and then I want you to start kind of thinking through solving it. And then we'll work it together. You have to think through what's going to be the most logical one to make go away. If there isn't an easy fix, it might be a double multiplication. And then think through your signs. Make sure if you're making your x's go away, you got to make one of them negative. right, so thinking through this, right, kind of think critically through the whole problem before you do any work. I've got 2x and 3x. They don't cancel each other out. I got -9 or -7 and -9. Those don't. I can't make a 2 a 3 by multiplying it by anything. I can't make a 7 a 9 by multiplying it by anything. So that means it's a double multiplication. So if it's a double multiplication, I have to decide ahead of time which one am I going to make go away. And I'm going to pick the x's just because I'm still going to have to do some kind of sign because the two x's match signs and I need them to not match. The two y's match signs. So I'm going to go ahead and make the x's go away. So that means I'm going to put brackets around top and bottom. And since I'm making the x's go away, I'm going to crisscross their coefficients. So the bottom coefficient is 3, so I'm going to multiply the top by a 3. The top is 2, so I'm going to multiply the bottom times 2. And before you distribute, think through your signs. 3 times 2 is +6. 2 times 3 is +6. I need one of them to be negative, so I'm going to pop a negative on one of them. It doesn't matter which one. Okay? Now, distribute through. So in the top equation, I'm going to distribute that 3 all the way through. So I have 6x. 3 times -7y is -21y. And 3 times 6 equals 18. And across the bottom, I have 2 times 3x, which is -6x. So I got what I wanted with my x's. -2 times -9 is +18y. And -2 times +12 is -24. Now I'm ready to draw my line because I've done manipulation on both. And I got what I needed. I got 6x and -6x, right? The numbers match, the signs are different. So they zero out or cancel out. Then I combine my y's. I got -21y and 18y, which is -3y. Make sure you take the sign of the bigger when the signs are different. And then 18 and 24, again, the signs are different, so I subtract. And I take the sign of the bigger, which is negative. I need to keep working now to get that y isolated, so I divide by a -3 on both sides, and I get y equals +2. Now I'm ready to take, right, what I know about y, which is that it equals 2, go back into either one of the equations. I'm just going to pick this bottom one. And I'm going to rewrite that bottom equation. 3x minus 9, parentheses where the y was, equals 12. And now I'm going to plug in the 2 that I know about y. And of course, I'm going to distribute first. So I get 3x, -9 times 2 is -18, equals 12. I'm going to add 18 to both sides because I want to get all of the whole numbers over to the right. So that leaves me 3x equals 12 plus 18 is 30. Now I divide because it's attached by multiplication, and I get x equals 10. And then my last step is to write my answer 10, 2 as an ordered pair. How'd you guys do on that one, doing it by yourself? Pretty good? All right, last one, and then you'll have about 15 minutes to work on your homework in class. So kind of sit for a minute and critically think about what goes away easy, if not quite so easy. Is there a 1 multiplication, or do you have to step it up to 2 multiplication? All right, so let's kind of critically think through this. We've got 12x and -4x, and then we've got -9 and +3 on the y's. So either one of them would work. Let's just do the x's because they're opposite signs already, and I can easily make a 4 a 12. So since I can make a 4 a 12, that means it's just going to be a single multiplication one. I don't have to multiply both. And again, think through your signs. It's 12x on top. 3 times -4 is -12x, so that gives me my opposite signs I need. So I didn't do anything to the top. And again, right, don't be lazy and take that extra minute to rewrite it, because you really want your new equations stacked right on top of each other. All right, so I didn't do anything to the top one. I rewrote it. Now I'm going to distribute that 3 through the whole bottom equation. That's going to give me -12x. 3 times 3y is +9y. And 3 times 0 is just 0. Now that I've got my 12x and my -12x stacked on top of each other, I'm ready to reduce each column or combine all my like terms. 12x and -12x cancels out. That just so happens -9y and +9y also cancel each other out, leaving me 0. 0 and 0 on the other side is 0. So when you get 0 equals 0, what's my answer? Good, infinite. So you still can have special cases here. You still can have your variables disappear and have infinite or no solution, or you're going to have an answer of an ordered pair, okay? So really quickly, just think through the steps, right? Critically look at your problem. Decide which variable to make go away, if it's a double or a single multiplication, and then right before you distribute, always think what your signs are going to be, and do you need to make one of them a negative? All right. For those of you at home, go ahead and hit load and pull it up on Kami, show all of your work and submit it through Kami. And if you have any questions, shoot me an email.